It can be bewildering when you first sit down and dig into a new data set. There is a lot of information that you need to digest quickly. In this exercise, you'll get practice on what it will be like when you take your exam. Generally, the first 15 to 20 points of PA are just based on data exploration. You'll need to be able to create graphs and to look at summary statistics. That's what this exercise will do. The dataset is from the UCI Machine Learning Repository, which is a massive archive of datasets. Task 1. Examine the target variable. Comment on the values of the target and what they represent. Well, let's look first at the data dictionary. This will always be at the end of your project statement. On the very bottom here, I see that the target Y has the client subscribed to a term deposit? Yes or no? Then there are a number of other variables related to the person's age, their education, their housing, and other demographics. So I would first go into RStudio and then load up my data set. Then I would just note that there will be different template codes provided. The first will remove a column. This code here will convert a character variable to a factor. This code will exclude certain variables, combine factor levels, and so forth. In general, you don't need to use this template code if you know how to do it on your own. However, there's no need to become an R expert on PA. Everything that you need will be provided for you, and the minimal changes that you'll need to make are things like the names of variables. If I use the count function, I can get an accurate idea as to the number of values in each record. So here I can see that most policies are not subscribed. This means that the class is imbalanced. This presents a problem for some types of machine learning models because the majority of the data is for examples for people who haven't subscribed. So the model will be accurate for these people, but maybe less accurate for the subscribers. So all of this information I would be writing down in the Word document here. So to start, I would give a description of your target variable. The target variable Y is whether the person has subscribed to a term deposit. The predictors are client data, variables related to their last contact with the bank, the month and day of the year, the number of times that they have been contacted in that campaign, as well as economic indicators. The target is imbalanced, as I just described. And now, for task 2, choose 2 categorical variables and look for trends in the percentage of subscribers. So as you could see, there's multiple ways that you could have answered this question. Often for a PA, questions will be open-ended, and it will be up to you to make a choice as to which variables you want to look at or which type of graphs you want to use. So in this case, I chose to look at all of the variables, and I did that by just copying and pasting this code here. And then I changed the name of variable to the categorical variable. I then noticed that the day of the week and education fields had interesting properties. I say the most subscribers sign up in the middle of the week from Tuesday to Thursday. So as you can see, Tuesday, Wednesday, and Thursday have the about 12% subscription rate, whereas Monday and Friday are only 9 to 10%. Signups are less common on these days, and there are no records on Saturdays, which makes sense because these are outside of business hours, Saturdays and Sundays. And now for this education variable. Notice that the largest group is people who can take out, is people who have a university degree with 13.72% right here. there are only 18 people in this unknown category who were illiterate, and so we don't give credibility to this figure right here, 22%. The unknown group on the bottom is 14%, but this could include people with or without a degree, so we discard this. So whenever you look at an average or a percentage, you always want to conclude what the sample size is. If there's not enough data for a particular group, then you should combine that factor together. So in this case, illiterate and unknown were combined together. So the project statement gave you specific guidance. It said use a cutoff of 50 observations. So how do you regroup variables into new categories? There are two ways. The first is to use the tidyverse library. If you use the if-else function, you can do it in one line of code like this. If you choose to use the base R version, then it will take you a little bit longer. This is generally how the SOA will give you the template code. So to do this method, you simply run this table function, and it tells you all the values here, and then you change the occurrences to the same order that you see. So the first one is basic 4-year, the second one is basic 6-year, basic 9-year, high school, and then instead of illiterate, you change this to other because you want that to be the new category, and then you do the same for the last category, which is unknown. Change that to other, and then when you run that, it will regroup. The dplyr method here is a little bit faster, but you do have to memorize some of the syntax. Regardless of which method you use, you should verify that your new variable has a reasonable number of values by looking again at the counts. So here, after I've run this code, I can see that there's the new other category. Question 2. Decide on which variables, if any, to remove. Read the data dictionary, and if appropriate, discard any variables that you believe should be discarded and explain your reasoning. So I would just read through the data dictionary's descriptions, and I won't do that all in this video, but if you did this, you would have noticed the duration variable. This says this is the last contact duration. So people are called and asked whether or not they want to buy a loan. Oh, I should say this is the actual duration, the length of time that they were on the call with the sales representative. So if it was a 5-second call, if they hung up immediately thinking that it was just an annoying telemarketer, of course they wouldn't have purchased a loan. So this highly affects the output target. Yet the duration is not known before a call is performed. Also, after the end of the call, Y is obviously known. Thus, this input should only be included for benchmark purposes and should be discarded if the intention is to have a realistic predictive model. So that tells you right there that you should delete this variable from the data. The way to do that is right here. So you would just say df, well actually you want to copy this down to your own code chunk like here and say df contact is equal to null. And if you're using dplyr, you can also do df and then select minus contact. Task 3. Examine the numeric variables. Comment on the statistical summaries and histograms. So the data here from task 3 will give you the summary for all of the numeric variables. And this tells you the min, the max, the mean, and the median, and then these histograms. So the histogram shows the distribution of each of the numeric variables. And what you're really just looking at is the shape. So you can see here the age variable gets cut off right at about 65. So most people are under the age of 65. When building a predictive model, we recommend creating a separate indicator variable whether the person is over or under age 65. This will help linear models to take this into consideration, because if you just include age as numeric, that will not work well with a GLM. A campaign, you notice, is highly right skewed, meaning that there are some values which have a very high campaign, but most values have a very low value. If you were using a predictive model, it would be a good idea to take a log transform of this variable. The consumer confidence index here, what does this actually represent? Because if you want to know if a variable's values are reasonable, it's a good idea to know what the definition is. Consumer confidence index, well, it doesn't actually tell you. So unless you are familiar with what an economic index is, you can't really justify whether an observation is an outlier or if it's an error or something else. So be very clear when you describe that in your report. Just say that the data dictionary does not provide an interpretation of these values, and so we are not sure how they should be interpreted. Because we notice that these are negative values, right? But maybe consumer confidence index should never be negative. Maybe it's a strictly positive number. There's no way to tell. Same with these price index, employee variable rate, and so forth. The p-days variable was interesting. This was converted to a categorical variable, and so the histogram is not shown above. Let's look at that. So let's do count p-days. So first of all, what is the definition of that? The number of days that passed after the client was last contacted from a previous campaign. 999 means the client was never contacted. So you could actually say that that's a missing value of sorts. Or is it? I wouldn't say that it's missing, but I would say that it's highly nonlinear. So if you look at all these points, almost 40,000 of them have never been contacted. And so a good method is to convert this to into a categorical variable. The way that I would do this would be to use bins. You could also create a separate variable that would be 1 if the value was 999 and 0 otherwise. And then include that in addition to the numeric variable of p-days. I think that this bin value, so if you wanted to use the bin variable method, you should use the case when statement. This is very similar to case statements in SQL. So you just adjust case, and then when p-days is between 0 and 5, say 0 and 5. When it's less than 10, say 0 to 10. And when it's 999, say none. And then be careful to remove the original variable. Otherwise, you'll have a redundancy in your data, and that will create a conversion. It will create an issue with your generalized linear models. So then, once you do that, of course, you want to count the values of your new variable to make sure that they are reasonable. And yes, you see that there are the 40,000 policies in that none category. And then you want to actually relevel your factor variables. Now this is a step that's important for generalized linear models. What it does is it sets the base factor level to the one that has the most observations. If I just look at summary of DF, well, first of all, I just see that these are characters. But if you were to fit them into a GLM, they would automatically get converted to a factor. So like, what if I did levels of DF job, for instance? Well, it says none, right? Because there are no levels to a character variable. What if I say as.factor? The first level is just going to be the alphabetically first letter, which is A for admin, B for blue collar, and so forth. But if you look at DF count job, you see that the most popular is it admin? Oh, it is admin, and then second is coincidentally blue collar, but then third is technician, T, right? Whereas if you look at the levels, the third level is entrepreneur, right? So to set the factor levels so that the base level always has the most observations, and in this case it's just coincidental because A is for admin and A comes first in the alphabet, you use this bit of code here. The SOA template code has a different section for releveling factors. However, this frequently has errors if you're using any tidyverse functions on factor variables separately. We recommend that just remember these lines of code, just mutate if is character factor infrequency, so that you don't encounter these technical difficulties on the exam. Task 4 is to examine the factor variables. Inspect the bar graphs for 3 factor variables that you did not previously inspect in task 1 and comment on any trends. So you could just look at several bar graphs, and R will give you output from a number of different graphs. So what your job as an actuary is to find the pattern. So like if you were to look at, marital status, you could on the left here see the percentage of people, and on the right the total number of people. So you can see that the highest subscription rate is for the unknown group and the single group. However, the married group has the most number of people overall. So whenever you see this data, try to think of an explanation. Like, people who are married may have more financial obligations because they have to save for their kids' college fund and so forth. And so they may be more hesitant to get into debt. They may be more financially responsible, for example. For a university degree, notice that the subscription rate is highest for people who have a university degree. Maybe this is because they're getting into college debt, or they don't yet have a full-time job, so they need to take out a loan to pay for a car or something like that. For housing, notice that most people well, what actually is housing, first of all? This is do they have a housing loan? So do they have a mortgage? Most people do, in fact. And the people who do have a mortgage, well, have about the same subscription rate as everybody else. So that's not a very interesting variable in this context. What about loan? Loan is, do they have a personal loan? So you can see most people don't have a personal loan, but again, there's very little difference in the subscription rate based on this variable. So it's not that interesting. So you could look through all of the other variables and just look for any patterns and comment on them. So I noticed that the bar graphs below shows the percentage of people as well as the number of people. The most common jobs are admins, blue-collar workers, and technicians, but the highest subscription rates are for students and retired people. These people do not have a consistent source of income, and so it makes sense that they would require a loan. The same graph for marital status shows that divorced people are less likely to have a loan than married or single people, shown below. And it's actually better if you can put your commentary on the same page as your description. The subscription rate for unknown group is highest on the left, but this does not represent a significant number of people on the right. The largest group is for married people here. Most people have a mortgage, as you can see here, and the subscription rate is highest for this group right here. Yeah, so it's actually, it's very close. It looks like this top has a slightly higher percentage, but maybe in this case it would be a good idea to include the numeric value as well. And that's all for this video. You might have found different variables, different discoveries. Regardless of which variables you chose, just be sure to do a good job of describing your findings in the report.